Hello dear students, welcome back to a new video. In this video we're going to solve section 3.1. Question 1, it says what is the difference between a solid and a fluid? A solid cannot flow and it cannot change its shape, but a fluid can change its shape and it can flow too. What is the difference between a gas and a liquid? A liquid, guys, has a definite shape, but a gas doesn't have a definite shape. Which one of the following objects in a tub will float in a tub of mercury? Okay, all of the objects are less than density except gold. Okay, gold is denser than mercury, so B, C, and D are all going to float, except A, which is a solid gold bead. It's going to sink. Sorry. Now you have question 3. Question 3, it says a 650 kilogram weather balloon is designed to lift a 4,600 package. What volume should the balloon have after being inflated with helium at 0 Celsius and 1 atmospheric pressure to lift the total load? Okay, so it needs the volume of the balloon. Now guys, let's write the givens first, okay? And then find out the volume, calculate the volume. Now guys, you have mass of the balloon. Let's just write MB. It's equal to 650 kilogram, okay? You have mass of the load, let's just write mass L. It's equal to 4,600 kilogram. This is the amount of load that the balloon can carry. You have the balloon is inflated with what? It's inflated with helium. So we are going to need the density for helium 2, which is equal to 0.179 kilogram per meter cubed. You also need the density of since the balloon is in the air, okay? So you are going to what? You are going to need the density of the air too. So 1.25 kilogram per meter cubed. Now guys, look, it needs what? It says volume is equal to what? V is equal to what? Now we are going to say FB, which is what? Which is the fluids part. Oh, let's write this in a different color. You have FB, which is the fluids part, okay? You're going to use the givens that you have for the fluid here. Then you have what? You have FG, which is the object or the loads here, the part of the load. Now look guys, you will say what? You will say mg, m, mass of the air, multiplied by gravity is equal to what? It's equal to m naught, mass of the object, multiplied by gravity. Then, because gravity is the same in both sides, it's going to cancel, okay? Then, mass of the air, guys. As you remember in the previous video, we said that density is equal to what? Let me write this one here. Density is equal to mass over volume, okay? To find density, guys, we will multiply density. To find mass, we will multiply density by volume, okay? Now, instead of writing m air, I'm going to write what? I'm going to write rho v, which is equal to what? Which is equal to m naught. Now guys, look at this m naught too. M naught is the mass of the object. Now mass of the object, guys, m naught, I'll write this a different color too. So m naught. Add all the masses that you have. You have what, guys? You have mass of the balloon, mb, and you have mass of what? Mass of helium 2, okay? Or let's write mass of you have mass of the loads too. And you have what? You have mass of helium 2, okay? Instead of writing m naught, let's just write here m of what? M of the balloon plus m of the load plus m of helium, or mass of helium, okay? Now guys, look, instead of writing mass of helium, can I write something else? You have what again? Mass of density of helium, which is equal to mass over volume. To find mass, we will say rho of helium multiplied by volume. Okay, so instead of writing this one, we can write what? We can write rho V. Rho of what? Rho of helium, H. And this is what? This is of air. Careful. Okay, now let's rearrange the equation. Since, guys, we need volume, okay, we need volume of the balloon, we are going to put these close together so we can later rearrange the equation. So we will say this one will be coming here. So density of air multiplied by volume minus density of helium multiplied by volume is equal to what? It's equal to this. Okay, it's equal to mass of the balloon plus mass of the load that you have. Now, V is common in both of these, okay, because it's the volume of the balloon. So we are going to take it as a common. So you'll say V, then you have density of air minus what? Minus density of helium. And this is equal to what? This is equal to mass of the balloon plus mass of the load. Since you need volume, guys, divide all of this by density of air minus density of helium. Then again the other side too. Mass of the air minus, density of air minus density of helium. Then this is going to cancel. Okay. Then you have what? You have volume, which is equal to mass of the balloon plus mass of the load, all divided by what? Divided by density of air minus density of helium. Okay, then this is equal to what, guys? This is equal to 650, which is the mass of the balloon, plus mass of the load, which is equal to 4,600, all divided by what? Mass of the air, which is equal to 1.29 minus density of the helium, density of the air subtracted by density of helium, 0.179. Calculate this number and you will get 4.7 times 10 to the power of 3. What's the unit? This is volume. Okay, careful, mind the unit, which is equal to cubic meter. Okay, this is the volume of the balloon. This is question 3. Now, guys, we have question 4. Question 4, it says you have a submarine. Question 4, it says a submerged submarine alters its buoyancy so that it initially accelerates upward at 0.325 meter per second squared. What is the submarine's average density? Now look, guys, you have acceleration, which is equal to 0.325 meter per second squared. Okay, then you have density of the seawater, which is equal to 1.025 times 10 to the power of 23 kilogram per cubic meter. It needs what, guys? It needs the submarine's density. So the density of the submarine is equal to what? Now, guys, since you have acceleration, we are going to use a new equation here. Now look, guys, to calculate density of the object, the submarine that you have, we're going to use what? We're going to say that F is equal to FB minus FG. Okay, so the sum of all the forces that you have. Okay, now instead of this F, guys, F is equal to what? Newton's second law is equal to MA. Okay, it is equal to MA. I have acceleration and I'm going to use this equation. Now I can say FB minus FG is equal to mass multiplied by acceleration. Now instead of writing buoyant force, guys, this is the fluids part. Let me write this, and this is the object's part. The object part. Okay. Now instead of writing FB, which is the buoyant force, I can write what? I can write mass of the sea multiplied by what? Multiplied by gravity minus, instead of writing FG, I can say what? I can say mass of the submarine, let's just write sub, multiplied by gravity is equal to what? It's equal to, again, instead of writing mass, because this is this part has acceleration of the object of the submarine, so I can use mass. Well, let's just leave this part for the next step. Let's just write MA. Now look, guys, as you remember, density was equal to mass over volume. Mass was equal to what? Was equal to density multiplied by volume. Now guys, instead of writing M here, you have three M's: mass of the sea, mass of the submarine, and again mass of the submarine here. Instead of writing all these M's, I can write like this. I can say density of the sea, okay, multiplied by volume, multiplied by gravity, okay, minus density of the submarine, multiplied by the volume of the submarine, multiplied by gravity, is equal to what? It is equal to density of the submarine multiplied by V and multiplied by acceleration. Now guys, look, let's rearrange the equation. I have volume and I have volume. I'll write V is V multiplied, volume multiplied by density of the seawater. You have, let's make it smaller, density of the seawater multiplied by gravity minus density of the submarine. This is C, density of the sea, multiplied by gravity minus density of the submarine multiplied by gravity. Okay, I have taken volume as the common. Okay, now you have what? Can I just write this volume here and put this one here? It's the same thing. Okay, so I can say density of the submarine multiplied by, oh, let's just write acceleration. Okay, and volume here. Here guys, look, volume cancels with volume. Now take this one and put it here. Okay, now we will say, well, let's do that for the next step. So you have density of the sea multiplied by gravity minus density of the submarine multiplied by gravity, which is equal to density of the submarine multiplied by acceleration. Now look, take this one to the side. So you have density of the sea multiplied by gravity is equal to what? Is equal to density of the submarine plus, multiplied by acceleration plus density of the submarine multiplied by gravity. Okay, now look guys, you can take this one because it's common, density of the submarine, so you can take it as a common and you will see density of the sea multiplied by gravity is equal to, take this one as the common, density of the submarine, okay, all multiplied by acceleration plus gravity. Okay, now guys, it needed what? It needed the density of the submarine. Okay, so divide all of this by acceleration plus gravity, this side too, acceleration plus gravity, this part cancel with this one. Then you have density of the submarine, which is equal to density of the sea multiplied by gravity divided by acceleration added with gravity. Okay, this is the equation for finding the density of the submarine. So you have the density of the seawater, which is equal to 1.025 times 10 to the power of 3 times gravity is equal to what? Gravity is equal to 9.81 divided by, you had acceleration, which was equal to what? Which was equal to 0.325 plus 9.81 again, which is the rate of gravity. Add all of this together and you will get 992 kilogram per meter cubed. This is the density of the submarine. You have the last question, physics in action. Many kayaks are made of plastics and other composite materials that are denser than water. How are such kayaks able to float in water? Now, guys, first of all, the real density of all of these materials, of the kayaks, is the density of all the materials that are used to make this kayak, okay? Something else we can say is that the kayaks are designed in a way to displace a greater amount of water, okay? So if it displaces a great amount of water, then it's going to have a larger buoyant force on it. Therefore, they're not going to sink and they're going to float. Same thing with the example of the ship that you have. If you throw a needle or a nail into the water, it's going to sink and it's made of metal. But a large ship would not sink. Why is that? Because a large ship is able to displace a greater amount of water, okay? Therefore, it has a larger buoyant force, okay? This is it for today. If you have any questions, please ask me in the comment sections. Thank you and see you in the next video.